So in the last class, I have explained very basics about a mole concept now. So I just wanted to repeat the same thing for some time, then I will go for the new things. Okay. So what I discussed here is very basic thing. First one is like everyone knows this law of conservation of mass. What is that? Law of conservation of mass. Then next I have discussed about the application of this law of conservation of mass. We have one concept called principle of atom conservation. Okay. So what is the use of this? I will tell you once again. Then next, after this, I also discussed Avogadro's law. Avogadro's law, and along with this Avogadro's law, I discussed one more, Gay-Lussac's law. What is it? Gay-Lussac's law of combining volumes. These are the three things I discussed in the last class. Okay. First of all, just tell me, what do we mean by law of conservation of mass? Conservation of mass. See, most of you are here repeaters only, right now, like long term only. You have at least some basic idea on law of conservation of mass. And the next thing is, when I say mole concept, there is a topic called stoichiometry. What do we mean by stoichiometry? We will calculate amount of product formed from the reactants. Let us say carbon combining with oxygen forming CO2. It means in order to get 44 grams of carbon, how much 44 grams of CO2, how many grams of carbon I should use? These calculations we will do as a part of our stoichiometry. Okay. So now what I am doing is, before I discuss stoichiometry, because stoichiometry is important topic to be discussed, but most of the students will only learn stoichiometry. I have one more method from this law of conservation of mass to calculate the stoichiometric calculations in easiest way. Okay, I just wanted to give that before we go further into this law of conservation of mass and limiting reagent, excess reagent, all these concepts. Okay, yeah. So let me discuss this first law of conservation of mass and its further laws. Yeah. So what this law of conservation of mass says, tell me? Mass is neither be created nor be destroyed. The total mass of the total mass that we take in to the reactant side will be converts into product side. So if reactant side I am taking 20 grams of A and 20 grams of B, and finally our product side also should be, total mass should be how much now? 40 grams only. This basic law everyone knows. Okay, yeah. So now let us say this is LHS side, RHS side. So mass at LHS side will be equals to mass at RHS side. So this is what a law of conservation of mass. Let us take one example. The basic one is methane. I am writing combustion of methane produces carbon dioxide plus water. Okay. So now look at this. What is the mass of one carbon? 12. Everyone knows this? Yeah. Next, hydrogens are how many? So it is 16 this side. Next, first of all, look, the reaction is balanced or not first. Look at this. How many carbons are there here? 1. Here also it is 1, there also 1. Hydrogens are 4, so it should be total 4 hydrogens. Fine. Oxygens 2 plus 2. 4 hydrogens required, 4 hydrogen oxygen atoms. Here only 2 oxygen atoms are there. One molecule contains 2 atoms. So I can multiply this with 2. So everything is fine now. Yeah. So this is 16 grams reacting with, just check. So 2 into 32. So this is 64. Next, this side you check, carbon mass is 12 plus 2 oxygens means 32. This is total 44. Next, what about this one? 2 into hydrogens are how many are there? 2 plus 2 means each hydrogen weight is 1. Okay, that is 2 into 1 is 2 only. Okay, oxygens are how many? 1. So it is 16. So total how much? 18 into 2, 36. 36 plus 44? 80. This side also check. 80. So total mass is conserved or not? So this is what law of conservation of mass everyone knows. Okay, I don't want to write again the basic definitions, you know. During a chemical reaction, the total mass of reaction must be conserved. That is, the mass taken at reactant side should be equals to product side. This is clear. Okay. Now based on this, we can also say one more statement. During a chemical reaction, this is second or the modification of law of conservation of mass. What I am saying, during a chemical reaction, the atoms must be conserved. What I am saying, atoms must be conserved. Whatever the atoms present at the reactant side should present at product side. How many hydrogens you are seeing here? 4. Must 4 hydrogens present at the product side. Carbons 1 means there also it should be 1. This is for sure. So this is what, instead of saying law of conservation of mass, I can also say law of conservation of atoms also now. Can I say law of conservation of atoms? Okay, up to here it is clear now. Now see what I am doing. You know, these are called stoichiometric coefficients. Whatever the numbers we are writing in front of that equations, that elements or formulas. So what is the stoichiometric coefficient? Here we are seeing 1, here it is 2, this is 1, 2. It means, what is the use of the stoichiometric coefficient means, you can theoretically say, theoretically you can say that 1 mole of methane requires 2 moles of oxygen. If you want to burn 1 mole of methane, how many moles of oxygen required? 2 moles. Therefore, how many moles of carbon dioxide formed? 1 mole. And also 2 moles of water is formed. Instead of saying moles, you can also convert into weights. Sir, how can we convert weights? See, here I told you 16 grams. These are grams means weights only, na? Yeah. So 16 grams of methane requires 64 grams of oxygen forms. Clear, up to here everyone knows. Yeah. Now what I am saying is, I just wanted to go through this POAC method. See, first of all, before I go to this, you know, calculating molecular weights everyone knows now, and I hope you are also aware that number of moles means given weight of a substance by molar mass of a substance. Okay, how we got this formula? It's a very basic thing, like 12 grams of carbon is nothing but 1 mole. 12 grams of carbon means 1 mole. This is how you are saying 12 grams of carbon means 1 mole means it is an experimentally determined volume. They taken 12 grams of carbon, they checked it, they found, there is something called mass spectrometry. So in that meter, that instrument, given that in 1 mole, in 12 grams of carbon, they found Avogadro number of carbon particles. How many particles? Avogadro number. What is that Avogadro number? 6.022 into 10 power 23. So everyone knows this also. Yeah. So this number is nothing but Avogadro number. So that Avogadro number in chemistry we are calling it as 1 mole. Like dozen, 12 you are saying now. In chemistry when I say Avogadro number, that is 1 mole. Okay. So that 12 grams of C12 carbon is how much mass? 1 mole. So now instead of giving you 12 grams, now I am giving you some n grams, otherwise some W grams. How many moles I am asking? How to calculate how many moles? What is the value of this n I am asking? What you are going to do? Tell me for this. Number of moles, n is equals to, see this number into this number. It means n into 12 equals to 1 into W. It means W only. So then n equals to W by 12. So 12 is nothing but molar mass of carbon, I can say. What is that? Molar mass of carbon. So let us generalize this formula for everything, not only carbon, as given weight by molar mass. Clear everyone up to here? So now what I am giving you is 6 grams of carbon I am giving you. How many moles it is? 6 by molar mass of carbon in the molar mass of carbon is 12. So 6 by 12. So that becomes 1 by 2. So half mole you can say. Okay. Otherwise 24 grams of carbon, 2 moles. Everyone are getting this. Okay. So like this, if I say carbon dioxide there, so instead of giving 44 grams, I am giving 88 grams of carbon dioxide. How many moles it is? 88 grams of carbon dioxide means. So given weight is 88. What is the molar mass of carbon dioxide? Carbon means 12 plus 32 for oxygens. So 44. So this is 2 moles. 88 by 44. It means 2 moles. This everyone knows. Yes. Now this is also fine. Okay. Now question will be like this in the exam. For burning, for complete combustion of 1 mole of methane, how many moles of oxygen is required? This is one model question. Otherwise, when 1 mole of methane is completely combusted, like burn, how many grams of water produced or how many grams of carbon dioxide produced is the question. What they are asking? How many grams of carbon dioxide produced or? So now what you need to do is, I have given you methane. Now what is my question? I am asking how many grams of carbon dioxide produced. So what is a common thing in both of these? Carbon is common. Now that's why the second modified theory, what I told you, during a chemical reactions atoms must be conserved. So here whatever the carbon atom is there, conserving, that means that is converting into our carbon dioxide. So total carbon atoms this side, that side should be same, or what is the weight of carbon this side should be equals to that side. Is this clear? So now what I am doing, how many carbons are there here? 1. So 1 into number of moles of methane. Why I am writing number of moles of methane? We have this methane molecule only now, because to provide this carbon dioxide I need carbon. That carbon is completely coming from methane only. How many carbons are there here? You write 1 into number of moles of that substance is equals to, here how many carbons are there? 1 into number of moles of carbon dioxide. So what is my question? When 1 mole of methane is combusted, it means number of moles only, this N methane means 1 mole is combusted. What is the weight? Weight by molecular mass. Weight by molecular mass of CO2. Now what is my question? What is the weight of CO2 formed? Now this one I want. What about CO2 molar mass? 44. Telsu kada, 12 plus 32, 44. Okay. So 1 is equals to given weight by molar mass, that is 44. From here weight will be, send this side, 44 grams we got. Is this clear how we are doing? Okay. Did I balance any chemical reaction here? No. Without balancing like this also you can do this method. Okay. Now one more question I will tell you. You just try this. 60 grams of ethane is given. C2H6. Ethane is given. Find weight of CO2 formed. No need of balance in the equation first. $88. Everyone same answer? Yeah. So how we are doing this, tell me? Just don't balance anything. Just write like this, C2H6 CO2. See, whatever the carbon we required for formation of CO2 completely coming from ethane only. Okay, ethane have how many carbons? So 2 into number of moles of ethane equals to this side in CO2 molecule how many carbons are there? 1. So 1 into number of moles of carbon dioxide. Done up to here? Yes. Next what I should do? 2 into, I given this thing, this data I provided. How I provided this is 60 grams. So number of moles means what? Given weight by gram molar mass of this substance. Given weight is how much? 60. Okay, 60. Ethane means C2H6. This is 24 plus 6, 30. So it is 30. Okay, this side we got 4. Number of moles means what I can write? Given weight by molar mass of CO2. Yes, next. So this is 4. This side weight by molar mass of CO2 is how much? 44. Then weight will be 4 into 44. Okay, how much it is? 16, 1, 7, 16, 70. 176. Is this clear or any confusions? Yeah. So if it is clear, now I am asking a question to you. Weight of CO2 is over now. Next, weight of water formed. Tell me how many grams of water formed? Everyone same answer? Yes, then it is correct only, I think. So how to do, tell me? How to construct this equation? See, from here only we need water. Okay. So how many hydrogens here? So 6 into number of moles of C2H6 ethane equals to that side. This side? Yeah, we'll check, no worries. This side what I should do? How many hydrogens are there here? So 2 into number of moles of water you take. Do this first. Change it. Everyone? Yeah. Butane. How many grams are given? 116 grams. Yes, tell me. How many moles of, what is the weight of CO2 produced, I am asking, right? So no need to write anything like balanced equation and all. So take C4H10 gives CO2. Next, how many carbons this side? 4. So 4 into number of moles of butane equals to, here how many carbons in one molecule? 1. That is what we are doing here, applying POAC, like principle of atom conservation. Which atom we are conserving? That means you take how many carbons here? This side also how many carbons? 1 carbon, so 1 CO2. Done. Next, 4 into, what is the weight I given here? 116 by 58. It means it is around 2 times. Okay, this one and CO2. Done. We are done with the question then. Okay, so what we can do next? Number of moles means given weight by its molar mass. Molar mass is how much? 44. So 44 if I send this side, so 8 into 44 equals to weight of CO2. So how much it is? 352. That's it. Done? Same answer everyone? For water you tell me, don't ask me to do this now. Everyone? 180. Okay, no issues. Any other answer? I want different answers only, so that I can confirm. Some of you might not clear. Do it everyone once again. $180. Everyone 180? What I should do, tell me once again. C4H10 gives H2O. How many hydrogens? 10 into N H2O. Sorry, N C4H10 gives equals to how many hydrogens? 2 into N H2O. Okay, so this will be 5. Done. 5 into number of moles of H2O, how many? I mean this C4H10. How many moles given? I mean given weight is 116 by 58 means 2. So I can write this is directly 2. This side I want NH2O. So how much it is? 10. So number of moles of water is 10 moles. Then weight will be number of moles into molar mass, because molar mass, like this we can write, molar mass of water is 18. So weight becomes 10 into 18. So 180. Clear everyone? Okay. No confusions. Now still you are having confusions. If still you have confusions, let's do few more questions. If not, we'll move forward. Clear? Okay. One last question. 5 moles potassium chlorate. What I am giving? Potassium chlorate is decomposed. Then calculate weight of O2 produced. Weight of O2 produced. Tell me this one. If you are done, then it's really good. First of all, you need to know decomposition reaction of KClO3. How it decomposes? KClO3. Yeah. Decomposes to give KCl plus O2. Okay. No need of balancing the equation. Yeah. Do it. Done? Enter. Any other answers? Okay. I want all 7 answers now. Yeah, so yeah, so now tell me what I told you, basic thing. What I am asking here, oxygen I am asking, where do we have oxygen? In the starting material, and here we have oxygen. So no need to worry about this because there is no oxygen in this. Whenever question is mentioning about one element, like oxygen here, where it is present? Here oxygen is present. So apply POAC to this one and its initial thing. Okay, so number of moles of KClO3 I should take, but how many oxygens are there? So 3 into N KClO3 I should write. This side equals to, what I should write? 2 into NO2. Is this clear or not what I am doing? That atoms should be conserved. What should be conserved? Atoms. How many atoms here we are saying? 3 into that moles, 2 into that moles. Done? Yeah, simplify now. So writing this equation is main thing. Any answer? $240. Yes, same answers everywhere. Yeah, so just put here 3 into how many moles? 5. 2 into weight by 32 for molar mass of O2. Next, this is 16 times. Next, weight will be 3, 5, 16. So this is 80 into 3, 240. Same answer everyone? Next. Okay. Next one. Avogadro's law, once tell me, what do we mean by Avogadro's law? So Avogadro's law says, you just take 2 containers having equal volumes. Let us say volume 1 liter, here also 1 liter volume. Okay, but I have gas here, O2, here something like N2. Measurements is done at same temperature and pressure. So at constant temperature and pressure, equal volumes of any gas contains equal number of molecules. For example, in this container of 1 liter volume contains some 5 lakhs of O2 molecules. How many lakhs? 5 lakhs of O2 molecules. Then same volume gadi ikkada, same volume na 1 liter means how many N2 molecules will be there here? Ida kuda 5 lakhs untayi. Enduku? At constant temperature and pressure, equal volumes of different gases contains moles. Whether it is different gases, same gases, no matter. They contains equal number of molecules. So you can simply say volume is directly proportional to number of moles or number of molecules at a constant temperature and pressure. Okay, whether you take, for example, here 5 liters I am taking. 5 liters contains X number of O2 molecules. Here also I am taking 5 liters. Then what happens? how many molecules of N2 will be there? Here I am saying X molecules, here also X molecules. Equal volumes, equal molecules. Okay. Now, can I say there are two containers like V1 having N1, like just remove that proportionality, and V2 N2. Okay, so this relation also we can get from here. Okay, done up to here. Next one, there is a condition called NTP condition. What is it? NTP or STP conditions are there. So at these conditions, okay, NTP means you can take 0 degrees Celsius and 1 atm pressure. 0 degrees Celsius, 1 atm pressure. So 0 degrees also considered to be 273.15 Kelvin also. Anything can be mentioned. So at this temperature, see temperature at this temperature means temperature is constant or not? Temperature value ఇచ్చారంటే అది constant కదా. So temperature is constant, pressure also constant. So at this constant temperature and pressure, so they have considered, they have observed a gas, a container. They have observed in a gas container having 22.4 liters. How much? 22.4 liters. So this much of volume of a gas is equivalent to 1 mole. 1 mole of gas. So 1 mole of gas, what is its volume you should say? Whenever we say 1 mole of a gas, its volume will be 22.4 liters at NTP. If I change this temperature pressure values, these quantities also changes. So this is valid only at NTP condition. Remember that. Okay. Gas is equivalent to 1 mole of gas. Okay. So 1 mole of gas is nothing but, see, number of moles is nothing but given weight by molar mass. If I say 1 mole, this is 1 mole, weight by molar mass. From here what I can write? Weight equals to molar mass. So 22.4 liters of a gas at STP or NTP is nothing but 1 mole of gas. 1 mole of gas is nothing but its quantity equals to molar mass. So for example, there is a container having 1 mole N2 gas. How much we have? 1 mole N2 gas. Mari container volume ఎంత ఉంటుంది ఇప్పుడు ఇది NTP condition అయితే? What is the volume of this container? I should say it as 22.4 liters. Okay. Lopala 22.4 liters of N2 gas is there, I can say. What is the weight of that gas then? 1 mole of N2 is nothing but molecular mass of N2. How much? N2 యొక్క molecular mass ఎంతమ్మా? 28 only now. So you can say it as equals to molar mass. So 1 mole of any gas is nothing but its weight equal to its molar mass. Weight of that gas equals to molar mass. So I can also say this is equals to molar mass of that gas. So simply at NTP condition, 1 mole of any gas occupies 22.4 liters of volume or have a mass of equals to its molar mass. These lines are clear now? Yeah. Then we will slowly enter into some questions. Okay, I am giving you 5.6 liters of H2 gas at NTP. Calculate weight of H2. Done? Very simple. ఈ క్వశ్చన్ నేను చేస్తా, నెక్స్ట్ క్వశ్చన్ మీరు చేయండి, లేకపోతే ఈ మోడల్ మీరు ఇంకా చేయలేదు కాబట్టి. సో వాట్ ఐఎమ్ సేయింగ్, 5.6 liters of gas at NTP condition. What is its weight I am asking? Simple. We know 22.4 liters means mass equals to 1 mole, like number of moles like 1 mole, or its molar mass we know. So given volume into then 5.6 liters equals to some x number. Find this x. Okay, so 22.4 liters is nothing but 1 mole, I know. Then 5.6 liter means n moles. Find the n value. Em cheyali cross, you know, no unitary method. Yes, tell me that. N is equals to number of moles equals to 5.6 by 22.4. So we can generalize a formula now here. Yeah. ఈ 5.6 ఈ దీనిలో ఇది ఎప్పుడన్నా వస్తుందో చూసుకో, అంటే 56/224 56 టేబుల్లో ఇది ఎప్పుడు వస్తుందో చూడు. 4 జా చూడు ఒకసారి. ఏంటిది 1/4 మోల్. నేనేం అడిగినా వెయిట్, అంటే వెయిట్లో కన్వర్ట్ చేయి. ఒకసారి ఇక్కడ పెట్టు, ఎట్లా చేస్తున్నావు చూద్దాం. ఫస్ట్ కంఫర్ట్గా ఫీల్ అవ్వండి, ఏం ఇబ్బంది పడాల్సిన పని ఏం లేదు ఇక్కడ, ఓకేనా. చాలా ఫ్రెండ్లీగా ఉంటారు ఇక్కడ ఎవరైనా, ఓకేనా. యా 1/4 నైస్. ఇప్పుడు నేను ఏమడిగినా నెక్స్ట్ వెయిట్ అంటున్నాం కదా, వెయిట్ చేసేసి ఈ మోల్స్ని వెయిట్లో కన్వర్ట్ చేయడం తెలుసు కదా. నెంబర్ ఆఫ్ మోల్స్ ఈక్వల్స్ టు కన్వర్ట్ చేయి. నీదమ్మా అంతే చేసేసి. ఏం చెప్తున్నావు అసలు, ఎందుకు వచ్చింది 1/4? అది క్లియర్గా రాస్తే బాగుంటుంది కదా, నీకు కూడా క్లారిటీ. అసలు అది ఎట్లా వచ్చిందంటే నెక్స్ట్ ఏం చేద్దాం, ఇంటూ హైడ్రోజన్ వెయిట్ మోలార్ మాస్ ఎంత 2. ఓకే 1/2 అంటే 1/2 గ్రామ్ అన్నట్టు. ఓకే, సో హౌ మెనీ మోల్స్ మా దిస్ ఈస్, see now we got a formula. Number of moles is equals to, when volumes are mentioned, number of moles is nothing but in the denominator it is 22.4 liters all the time, because it is for 1 mole. Now here you write given volume given at NTP, volume given at NTP by 22.4, volume given at NTP is how much, 5.6 by 22.4, that is 1/4. Then 1/4 moles convert into weight. After getting moles, weight by molar mass, then weight will be N into molar mass. This is 1/4 into molar mass of H2 is 2. So it is 1/2 grams, or I can say 0.5 grams. So what is the weight of H2 used? 0.5 grams. Everyone clear? Okay, next. So previously I asked one question like ethane 30 grams, 60 grams of ethane given. Check once, go back. 60 grams of ethane given. Weight of O2 produced I asked. Okay, no, weight of CO2 produced I asked. So you can also calculate now. Beside that you write, now don't do now, just write it as a question. Beside that question itself, if you want you can write. what you will write? What is the weight of, what is the volume of CO2 produced at STP? Volume of CO2 produced at STP. Okay, do that question after the class. Next, here continuation to this, giving you 0.112 liters of methane gas at NTP. Calculate weight of methane. Do this first. Weight of methane. Yeah, that's it. Yeah, what is your answer? Simple. First, what to do? Moles. Yeah, how many moles? 0.112 by 22.4. So this one I can write 11.2 into 10 power minus 2 by 22.4. Okay, how many times? 2 times. So this is 5 into 10 power minus 3 I can write. Why I am writing like this? Half means 0.5 into 10 power minus 2. So 5 into 10 power minus 3. Okay, done up to here everyone. Yeah, next, weight. How to find number of moles into its molar mass? Number of moles is 5 into 10 power minus 3. Molar mass of methane 16. So it is 80 into 10 power minus 3 grams. Next, see this one, 0.8 grams you will get. Yeah. Still confusion? Next. Once again.
0.08.
This one? Yeah. 0.08. How many decimals are there here? 3, na? I mean, so 3. That's it. Yeah. Next. This many grams. So Sometimes they will give you grams and they will ask you volume occupied. For example, 16 grams of methane occupies how much volume at NTP? How much 16 grams methane means? 22.4. Now they will say 1.6 grams. Yeah, very easy. See, 16 grams means 22.4 liters of volume at NTP. Now 1.6 means divided by 10 here. There also you divide with 10. 2.24 liters. Okay, basic understanding. Then next you just remember this values now. Every time, most of the cases you will see something like this. Question contains 11.2 liters, 5.6 liters. Okay, 11.2 liters is nothing but 11.2 by 22.4. How much? It is 1 by 2. Sometimes 5.6 liters. This is nothing but 1 by 4. And 5.6 by 22.4 just same ostadi. 1 by 4. Okay, or otherwise 44.8 liters they will give. Okay, just be clear with these values, that's it. So this is 2 moles. Okay, that's it. All this story is applicable only at NTP conditions. Okay, yeah. Next, stoichiometric calculations we will do now. Okay, before that, just see H2. Okay, you take any equation. Yeah, let us take this very fundamental and textbook example. HCl only. First of all, look at this equation. Is it balanced or not? Mention their physical states: gas, gas, gas. What is the stoichiometric coefficients we have? 1 mole, 1 mole, 2 moles. Okay, this is stoichiometric equation. Next, instead of saying 1 mole, I can say 1 volume of H2 combining with 1 volume of Cl2. Why I am saying volumes? Because from Avogadro's law, volume is directly proportional to number of moles. I can say in terms of number of moles or in terms of volumes also. ఇక్కడ 1 mole అనే బదులు నేను ఏమనొచ్చు 1 వాల్యూమ్ అనొచ్చు. 1 వాల్యూమ్ ఏంటి సార్ అని అంటే క్వశ్చన్లో ఫర్ ఎగ్జాంపుల్ 10 ml ఆఫ్ H2, 10 ml ఆఫ్ Cl2 ఆర్ కంబైనింగ్ గివ్స్ హౌ మెనీ ml ఆఫ్ HCl at NTP అంటది. అప్పుడు ఏం చేయాలి మనం? జస్ట్ సి ఇది 1 ml అయితే ఇది ఎంత వస్తుంది? 2 ml. సో దిస్ ఈజ్ ఆల్సో 1 ml, దిస్ ఈజ్ ఆల్సో 1 ml. సో ఇట్ విల్ బి 2 mls. 10 అవుతాయి 20 ml. Is this clear what we are doing? So 1 volume of H2, 1 volume of Cl2 combines to produce 2 volumes of HCl, you can say. But this story is applicable only at constant temperature, pressure. Because we know Avogadro's law works at constant temperature and pressure. So by using Avogadro's law, this explanation is given by Gay-Lussac's. So what he say? Gay-Lussac's combining volumes. What is it? Gay-Lussac's combining volumes. Conditions: constant temperature, pressure. Okay. Now this is applicable only for gaseous. Applicable only for gaseous because Avogadro's law, where we discussed at constant temperature and pressure, equal volumes of any gas contains equal number of molecules I told you. That is gas only now. So it means this reaction also applicable for, this law is also applicable for gases. For example, I am writing here at room temperature, at RT, room temperature, or they mention it as 25 degrees Celsius. Methane combustion reaction is provided. Okay, so what you are going to say? At room temperature, what is the physical state here? Gas. This one also gas, gas. This one liquid. So I should not say that is like 2 volumes of H2O is produced. Why I should not say that? Because it is a liquid. For liquids it won't applicable, only for gases. So you can relate among these 3 only, not that one. Is this clear? Yeah. Done. Done with this also. Yeah. Let's go to these stoichiometric calculations now. So stoichiometric calculations means what we'll do generally like this. They will give N2 plus H2 gives rise to NH3. First you need to balance the equation ma. So 1 mole, here how many moles? 1 mole means here it is 2 nitrogen, so 2 nitrogen should be there. Next 6 hydrogen should be there, means here it should be 3. What is the mole ratio we got? 1 mole, 3 moles gives 2 moles. So this is as per the equation. First of all, every time write the equation. In order to do this stoichiometric calculations, you need to write the equation, take the balanced coefficients. After balancing the equation, take the coefficients. Okay. So now what is the use of these coefficients? Saying, see, theoretically, if you are doing this reaction theoretically, for every 1 mole of N2, how many moles of H2 required? 3 moles. Forms 2 moles. ఇది థియరిటికల్గా అంటే టెక్స్ట్ బుక్లో మనం చేస్తున్నాం. ఇఫ్ యూ వాంట్ టు డూ ఎక్స్పెరిమెంట్ ఆల్సో విల్ ఫాలో దిస్ వన్ ఓన్లీ. బట్ అమౌంట్ ఆఫ్ ప్రోడక్ట్ ఇంత వస్తుందా రాదా అనేది డిపెండ్స్ ఆన్ ఎక్స్పెరిమెంటల్ కండిషన్స్. బట్ వీ నీడ్ టు ఫాలో దిస్ thing only. Okay. Now what I am doing is, instead of giving you 1 mole 3 moles, I just wanted to give you 6 moles of N2, 6 moles of H2. What is the amount of how many moles of ammonia produced? మనకి రియాక్షన్ చేయడానికి మినిమం కండిషన్ ఏంటమ్మా? we required like 1:3 ratio of N2 and H2. Now what I am given 6 moles, asking how many moles of ammonia produced. How you are saying that 12 moles? See, for every 1 mole of nitrogen, how many moles of hydrogen we are using? 3 moles. Clearly listen here, for every 1 mole of hydrogen, how many moles of hydrogen is used? 3 moles. This is as per the equation. So in the same ratio we should get here also. For 1 mole, if it is 3, then for 6 it should be 18 కావాలి. But how much we have? So 6 ఇది enough మరి 18 ఉంటే enough అవుతుంది దీన్ని మొత్తం రియాక్ట్ చేయడానికి. So it means this is not in enough amount. This is less than the required. So you should say this as a limiting reagent. What you should say? Limiting reagent. Once again, which is a limiting reagent, how to find? So check as per the equation, as per the balanced equation, compare it the data provided here. See, for 1 mole we required how many moles of hydrogen? 3 moles. Now given question 6 moles of 2 substrates. For 1 mole 3 means, then for 6 it should be 18, but I have only 6. So this is less than my requirement. So I should call this is limiting reagent. Less quantity na limiting reagent. So this less quantity substance decides how much amount of product should be formed. See, for every 3 moles, how many moles of H is required? Hydrogen 1. Then for every 6 it should be 3 ki 1 కావాలని ఇచ్చినప్పుడు 6 కి ఎంత కావాలి? 2 సరిపోతుంది. How much we have? 6. I need only 2 moles. But I have 6 moles. It means remaining 4 will be excess. నాకు ఇది అవసరం లేదు. We don't use this. It remains as excess in the reaction. How much we are going to use here? 2 moles. So then for every 6 moles we will use 2 moles and forms how many moles? How to identify this? 3 ఉంటే ఇక్కడ ఎంత వచ్చిందమ్మా? Then 6 ఉంటే ఇక్కడ ఎంత వస్తుంది? 4. అంతే, 4 moles product form. Okay, ఇంకా ఇది మీకు అర్థం కాకపోతే one more example we'll take, we'll solve that, we'll come back to this. Okay, first of all, ఇప్పటిదాకా మనం ప్రిన్సిపల్ పిఓఏసి అన్నాం కదా, అది కాకుండా ఒకసారి స్టైకియోమెట్రిక్ క్యాలిక్యులేషన్ చేద్దాం. దేనికి చేద్దామని అంటే ఈథేన్ క్వశ్చన్ ఉంది కదా, అది చేద్దాం. సో C2H6 ప్లస్ O2 గివ్స్ CO2 ప్లస్ H2O. Okay, balance this equation first. 2, 3. So 4 plus 3, 7. 7 oxygens are there. So if I put here 7, it becomes 14 oxygens. So I should write here 7/2. Clear, everyone knows this. Yeah. Then after this, what is the mole ratio? 1 mole, 7/2 mole, 2 mole, 3 moles. Okay. Now my question is, weight of ethane C2H6 is how much I given previously? 60 grams, no? 60 grams here also, 60 grams. Calculate moles of CO2 and moles of H2O formed. So what to do, tell me first. 60 grams I given, na? Convert this into moles, because they are asking those are also moles, na? Easy calculation. First convert this into moles. For 1 mole I get, then for this moles how much I get? Do that. Hmm? 4 moles of CO2. 60 grams is nothing but how many moles of ethane? So 60 by 30 means 2 moles of ethane we got. As per the question, 1 mole requires, 1 mole gives you 2 moles. Then 2 moles gives you 4 moles. This is 4. What about this one? 1 gives 3, 2 gives 6. So these are simple answers. There is no concept involved here, limiting, excess, nothing is involved. Just simple calculations. But everyone got this first? Yeah. Then only we will enter into the limiting and excess reagent concept. Okay. Look at this. H2 plus, okay. What is my question is? 16 grams of O2 and 4 grams of H2 is provided. Calculate weight or moles of H2O produced, H2O formed. You do this, then you will get some clarity on limiting and excess reagent concept. Any answer? So first thing is to write a balanced equation. H2 plus half O2 gives H2O. First, balanced or not? Yeah, balanced. Then next. Here you can see 1 mole requires half mole produces 1 mole. So 16 grams of H2 or O2 means how many moles it is? Given weight is 16, its molar mass is 32, so it is 1 by 2 mole of O2. Okay, number of moles of O2 is 1 by 2. Next, 4 grams of H2 means moles. Given weight is 4, molar mass of this is 2, so it is 2 moles. So this is as per the equation, and as per the given data, H2 is 4 moles and O2 is half mole. Yes, tell me now. Easy. For every 1 mole we required half mole. Then for every 4 moles it should be 2 moles. But how much we have? Half mole. So this is less than the requirement now. So I can say this species as limiting reagent. This is my limiting reagent. After identifying limiting reagent, your calculation should be with respect to limiting reagent only. So for every half mole, how many moles of H2 is required? Then from here also, this is also half only now. So out of this 4, I can only use 1 mole. Remaining 3 moles will be excess. Clear? This is clear. Then next time. This is the limiting reagent. For every half, how much it is producing? 1. So here also half means how much it is producing? 1. Okay. So how many moles of water formed? 1 mole. So now tell me resultant mixture, how it is? Resultant means after completing this reaction, what are the things remaining? Excess reagent means definitely it remains excess. How much it is excess? 3 moles. Limiting reagent will be consumed completely. In a chemical reaction, limiting reagent will be completely consumed. The next H2O formed will be 1. Clear? Yeah. They may ask you in terms of weights also. Follow the same method. Yeah. Next. To the same question, I want to change the numbers now. Find this. Okay. O2. H2. Yeah. Find this. Same question. For production of water only, 64 grams of O2, 8 grams H2, how many grams or how many moles H2O is formed? What my okay. So some okay మరి ఓకే ఓకే 2 moles only. ఇక్కడ మరి ఎవరు చెప్పట్లేదేంటి? చేసాం కదా ఇక్కడ మనం వి డిడ్ దిస్ నా యా జస్ట్ ఇఫ్ ఇట్ ఈస్ 2 mole ఈ 2 mole లో మనం ఎంత వాడుకున్న వాట్ క్వాంటిటీ 1 mole I used, 1 mole remains excess. So here remaining resultant will be 1 mole extra, this will be 0, this will be 1. Okay. Next, do it for this question. well, let's see once. So what I should write? H2 plus half O2 H2O. So 1 half 1. Yeah. So this is 64 means 2 mole. 4 means this is also 2 moles. Yeah, tell me now. You will get clarity now. So here given 2 moles, here also given 2 moles. Yeah, identify which is limiting and excess. See, definitely for every 1 mole we require half mole. Then for every 2 moles it should be 1. But how much we have? 2. So this is more than requirement now. So it excess. So excess reagent. This is the limiting reagent. So our calculation should be done with respect to limiting reagent. It means what? Limiting reagent decides amount of product formed. Okay. So for every 1 mole we are getting 2. Then for every 2 moles it should be 1 ki 1, 2 ki 2. That's it. That is your answer. Done with these models? Yeah. So now here I given in terms of moles for easy calculation purpose. But examiner will ask you in terms of weights also. Means his main purpose is to waste your time in the exam. Okay. So how you will overcome this? By practicing more number of questions. Because mole concept everyone feel they knows. But their time should be balanced here. Okay, like there is like mindset of students is అమ్మాయి నాకు ఇది వచ్చు సో నేను చేయాలి అట్లా అందరు చేస్తారు బట్ కొందరే ఫాస్ట్గా చేస్తారు మిగతా వాళ్ళ టైం అంతా వేస్ట్ అయిపోతుంది సో యూ జస్ట్ ప్రాక్టీస్ మెనీ డిఫరెంట్ మోడల్ క్వశ్చన్స్ యూ కెన్ ఓవర్కమ్ దిస్ ఓకే దట్స్ నెక్స్ట్ థింగ్ ఈస్ స్టాయికియోమెట్రిక్ క్యాలిక్యులేషన్స్ ఆర్ డన్ జస్ట్ ట్రై టు ఆన్సర్ దిస్ స్మాల్ అసర్షన్ రీజన్ క్వశ్చన్. What's your answer? Mass of product formed in a reaction depends on limiting reagent. Yes. Next, limiting reagent reacts completely in the reaction. Correct only, na? Both of them are correct and correct explanation also. So A. Next. Try this very basic question. Third option. Any other options? First write the balanced equation of ammonia formation. Then check number of moles of hydrogen for production of 1 mole ammonia, like that. Then you put 20 moles ammonia. How many moles hydrogens? 30 moles. Simple. N2 plus H2 gives rise to NH3. Here 3. So 1 mole, 3 mole, 2 moles. This is fine. So in order to produce 2 moles ammonia, I required 3 moles hydrogen. In order to produce 20 moles, it should be 30 multiplied with 10. That's it. This should be 10 if I want to calculate. That's it. So answer H2 only now. So it is 30. If it is N2, 10. Done with this. So in next class we'll discuss about percentage yield, okay, and percentage compositions. Okay, any other topic remaining we'll discuss. So once summarize the discussion.